in this problem, we're dealing with a car that is riding through a hump with some velocity v, and the hump has some radius big r. So the car is driving right at the very top of the hump at its highest point. The first question is, okay, what are the forces exerted by the row at the highest point of the hump? So the first one is that the car is at the highest point of some circular trajectory. So there is some centrifugal force pointing downwards, like this, from the car towards the center of the trajectory. However, there's also a normal force by the hump that's pointing upwards, since the car is in contact with the road. And there are no horizontal forces acting on the car, so that's it for forces exerted by the road, since there is no friction. And we have that the forces exerted by the road is just this, just mg minus mv squared over r. So now the next question is, okay, um, if this total force exerted by the row is zero, then what that means is that the car will not be in contact with the road anymore at this highest point of the hump. And with that condition, we can calculate then what is the velocity that the car needs to have in order for it to not touch the road at the highest point of the hump. So we just equal this force exerted by the road equal to zero. We get rid of the m's. We can immediately solve for p. It's some very simple algebra. But then that p is just the square root of g, the gravity acceleration, times r, which is the radius of the hump.